Alright, we're going to do Trig Lecture 12.2 and 12.3 today. It is sort of a review of stuff that we've done in the past. As they say, as the old saying goes, repetition is the key to learning. 12.2 and 12.3, the student will use trig functions to solve right triangles. Remember that to solve a right triangle just means to find all the missing pieces of the triangle. You'll be given certain parts of the triangle, and you'll find the parts that aren't given to you using trig functions. And it'll look something like this. These are the types of problems you can expect to run into. And as I say, this is sort of a little review of stuff we've done in the past. Solve each triangle, round to the nearest tenth. So I look at this triangle, I look and I see what I've been given. We've been given triangle ABC. It's a right triangle, so I can just use regular trig functions. I don't have to use law of sines or law of cosines or anything like that. You can, but you don't have to. I am looking for side B. I'm looking for side A. And I'm looking for angle A. So I'm going to write those down over here. I'm looking for angle A, measure of angle A. I'm looking for the length of side A. And I'm looking for the length of side B. I'm going to put those in a nice box. Just give me a place to put them. And now I can just use my trig functions and find them. Well, I know that if this is 90 degrees and this is 27, I'm going to find this angle. These two, if this is 90, these two have got to add up to 90. So I'm just going to find the complement of 27. In other words, I'm going to take 27 and subtract it from 90, and that will give me the measure of angle A. So the measure of angle A is 90 minus 27. These two have got to add up to 90. 90 plus 90 is 180. The interior angles of all triangles add up to 180 degrees. So if these two have to add up to 90, 90 minus 27 is 63. That's got to be a 63-degree angle. And we've got that much of the triangle solved. And we don't have to round that because it's an exact value. Our instructions say round to the nearest tenth. Well, that's not necessary in this case. That's an exact value. Next thing I want to do is find either A or B. I'm going to use a trig function to do that. I can do it from a perspective of 63. Say the sine is A over 15 or the cosine is B over 15, or from a perspective from this angle right here, 27, the sine of 27 would be B over 15, the cosine would be A over 15. Since I'm going to try to find A first, and it doesn't matter which one I try to find first, but I just chose to find A first, I'll use this angle and I'll use the cosine function. I can say the cosine of 27 degrees is A over 15, and that way I only have one unknown. I could have just as easily said the sine of 63 is A over 15. So here we go. I'm going to say the cosine of 27 degrees is adjacent over hypotenuse, A over 15. I solved this for A by multiplying both sides by 15. I wind up with 15 cosine 27 degrees is equal to A. I just multiplied both sides by 15 and they canceled on this side. Then I'm going to evaluate this with my calculator and round it to the nearest tenth. And that will give me 15 cosine 27 is, excuse me, approximately 13.4 units. It could be inches, centimeters, light years, miles, whatever our unit of measure is. We weren't given a unit of measure, so I didn't bother listing one. Some teachers would like you to write the word units there. That would be fine. I'm not going to ask you to, but don't be surprised if somebody does. So we found side A. Now I'm going to find side B using a similar technique. We'll say, well, I could say from this perspective, the sine of 27 degrees is B over 15. That just gives me one unknown. Or I could say the cosine of 63 is B over 15. I'll get the exact same answer either way. So since I started with 27, I'm going to stick with 27, but it doesn't matter. I could go with 63 and just use the cosine function. But from here, I'll say opposite over hypotenuse. I'll say the sine of 27 degrees is b over 15. To solve this for b, I'll multiply both sides of the equation by 15. That will cancel on this side and leave me with b. And on this side, I'll wind up with 15 sine 27 degrees. Left off my degree symbol there. And that gives me b. I'm going to scroll this a little bit. There we go. And now I'm going to evaluate this with my calculator and round to the nearest tenth. 15 times the sine of 27 degrees is 6.8 approximately. So b would be about 6.8. I would put that up here, and that would be units again, miles, inches, centimeters, whatever. 6.8, if I haven't made a mistake. And these are the three parts of the triangle that I was looking for, so I would be finished. I found A, I found B, I found C, angle A, and I wrote them to where my poor old blind, bald-headed math teacher could find them in a box. If I was using a multiple choice, if I was taking a multiple choice, I would look for these three among the choices. And let's see if I got that key right here. Let's see if that's right. Yeah, I got it right. So that's the kind of thinking we're going to be doing. I'll do one more. In this case, we're just given one side. You know, we're not given any of the, I'm sorry, we're given two sides. We're not given either one of the angles. So I'm going to mark what I'm looking for. I'm looking for side B, angle A, and angle B. So I'm looking for angle A, whoops, kind of far away. Looking for the measure of angle A, the measure of angle B, and side B. Those are the three bits I'm looking for. Put them in a nice little box. Just give me a place to put my responses. And give me some room to work over here. So here we go. I'm going to find angle A first. It comes first in the alphabet, so I'm going to find it. I'm going to say, well, I know that from this perspective, this angle right here, the sine is 4 over 9. So I can say that the sine of angle A is equal to 4 over 9. To solve this for angle A, I'm going to take the inverse sine of both sides. This will give me angle A is the inverse sine of 4/9. And with my handy dandy calculator, I can say that A is approximately, and again, my instructions said, the last set of instructions we had said round to the nearest tenth, so that's what I'm going to do. I'm going to round this to the nearest tenth. Inverse sine of 4 over 9. Let's see if I can do that. I get about 26.4 degrees. Rounding to the nearest tenth. And so I'll come up here and I'll say, well, measure of angle A is about 26.4 degrees. Now, if I know that this is 26.4 degrees approximately, I can easily find this angle just by subtracting 26.4 from 90. So I'm going to say 90 minus 26.4 is equal to 63.6. That's what this angle will be. Because these two angles, the two acute angles, have got to add up to 90 degrees because this is 90, and 90 plus 90 is 180. So 63.6 if I haven't made an arithmetic mistake. So there's two of the angles. And if I find side B, I am going to use the good old-fashioned Pythagorean theorem. I'm going to say a squared plus b squared is equal to c squared. So I'll say 4 squared plus b squared is equal to c squared. That gives me 16 plus b squared is equal to 81. Subtracting 16 from both sides, I'll do that with my calculator so I don't mess up. B squared is 65 units. 65 squared, but we'll take the square root of both sides. And that should be 8.1-ish, about 8.1, which makes sense. The square root of 64 is exactly 8, so the fact that it's 8.1 it should come as no surprise. So this will be approximately 8.1. Notice I already had an equal sign up here, so I'll just put a dot above it. That's another way of saying approximately. Approximately, approximately, approximately. And this would be units, miles, centimeters, inches, so forth and so on. So these are the types of problems you're going to run into today. As I said, it's kind of like a blast from the past, having a little review over solving right triangles. And hopefully this makes sense. You can do this.